Now the next equation we're going to be asked to solve is 3 minus 2 over x minus 1 being equal to 1 over x minus 1 quantity squared. And you can see that the directions ask us to solve this equation using the method discussed in chapter number 6. And in that chapter we talked about solving rational equations, which this equation clearly is. Now it might seem a bit out of place to use that method for solving this equation in this particular module, when we've been talking about solving quadratic equations. Well, there are two reasons we want to do that. And the first is it's going to be really helpful, I think, to review the process that we talked about in chapter number 6. But the second reason is that you're going to be asked to look at this equation in a little different way by recognizing it as being an equation quadratic in form. And so by making an appropriate u substitution, you can turn this equation into a quadratic equation, then use the method that we've talked about right prior to this in this module. So I think it'll be very useful and helpful to compare the two different approaches. So let's now solve the equation using the method we talked in chapter number 6 about. And you remember that in that chapter, when solving rational equations, we said that one good thing that's always helpful to do in the very beginning will be to state any restrictions on the variable before we start solving the equation. So in this case, I think you can see that it's going to be that x cannot be equal to positive 1 is the restriction, because it would make either of those denominators 0, which would make then the fractions undefined. Now, why is it important to state the restriction? Well, when we multiply both sides of the equation here in just a moment by the LCD to eliminate the fractions from the equation, you remember that whenever you multiply each side of an equation by an expression containing the variable, it's possible to introduce what we call extraneous solutions. In other words, solutions that do not work or not solutions to the original equation. And extraneous solutions will always then match restrictions that we state at the very beginning. So that's why it's very important that we do that. So let's begin. We're going to multiply each side here by the lowest common denominator of the two fractions, and I think you'll agree that will be x minus 1 quantity squared. So if we go back to the left-hand side now, multiplying the 3 by that, we have 3 times x minus 1 quantity squared minus 2 times, and I think you'll see the denominator of that fraction will cancel into the LCD, leaving us with just an x minus 1. And on the right-hand side, the denominator cancels completely with the LCD, leaving us with just 1. So now if we go back to the left-hand side, we'll expand the x minus 1 quantity squared into x squared minus 2x plus 1. And next we'll distribute the negative 2, so it becomes minus 2x plus 2 is equal to 1. Now we'll go back and distribute the 3. So we have 3x squared minus 6x plus 3 minus 2x plus 2 is equal to 1. And now if we combine terms on the left-hand side, we'll have 3x squared, and we have a negative 6x and a negative 2x, which will produce then here minus 8x. And 3 and 2 added will produce 5, being equal to 1. So since we have a quadratic equation, we need to put it in standard form, which means we'll make one side 0. So 3x squared minus 8x, and subtracting 1 from both sides, we'll have 4. Then is equal to 0. Now, to solve the equation, it's always a good idea to see if we can factor the equation first. In this case, I believe we'll be able to do that. So we'll set up our two parentheses here. And we know that we have to have 3x and x as the first terms in each parenthesis. And I believe if we use 2 and 2 to give us a product of 4, and making both of these negative, will then yield, if we multiply back, the 3x squared minus 8x plus 4 being equal to 0. So now we'll next set each factor to 0. So we have 3x minus 2 being equal to 0, or x minus 2 being equal to 0. So now let's come up here where we have a little bit more room to finish this. So solving the first equation, we'll have 3x is equal to 2, x being equal to 2/3 as one possible solution. And solving the second equation, we have x equal positive 2. Now we note that neither of these solutions match the restriction we stated at the beginning, so we should be pretty confident that both of these are valid solutions to the equation.